Welcome everybody to another BIM broadcast. We are going live here today and we're going to be talking about some RAM on computers. We're going to be joined by, let me merge them in here. I'm going to get Anthony on the line. Hey Anthony, how's it going?
It's going good, man. Happy Friday. It's Friday, right?
Happy Friday to you as well. So we're going to be talking about some RAM. I know Buck's running a little bit late today, it would seem, so we'll be getting him in the call in just a moment here. But you were showing me just a second ago about a new form factor you guys might be building in. You're kind of experimenting on. Can you bring that up real quick? And it's right behind you on the desk, I think.
This is we're looking to see how far we could push the limits of this tiny little ITX enclosure. You know, at the very least, it might be our final choice on an entry level, like high performance, Revit box. But, the options for like 18 core processors aren't out of the question either.
Now, question for you on this, because I'm seeing that box looking a little small for a Revit box. The biggest thing that we talked about, I think, last time around in CPUs was cooling. And how are you going to be able to cool that thing? That seems like it's kind of tiny.
Yeah, that's the interesting part about that. It's limited to about 57 millimeters in height, like CPU cooling height.
Right.
So the difference is there's two 120 millimeter fans that would go on the bottom, which kind of really now all of a sudden creates like a wind tunnel effect.
Right.
So with typical air cooling, oftentimes it's just recirculating hot air, whereas this would be getting fresh air kind of shoved right through the cooler. And so far, like, the i5 doesn't have any issues at like 4.8, 4.9 gigahertz. We now need to like try the i7 in there and see what we could push that to.
Yeah.
Oh.
So you were saying something about you're working on some deals with the manufacturer of that box, right? And they're going to be doing a little bit of work with some of the cutouts and some of the pre-manufacturing, so you might be able to better liquid cool that too, right?
Correct. They were telling us with some simple like tweaking, they could get it to fit a 240 millimeter all-in-one cooler. So basically at that point, now that opens the door to like 18 core, processors. 64 gigabytes of RAM on like an 18 core Intel. You got a pretty stout, mobile compute box.
Right.
If they change the dimensions and lengthen it a bit, they could actually even put a 360 millimeter cooler. And really, then you could even start talking overclocking an 18 core processor and something not much bigger than that. Maybe adding like 2 more inches in length. So.
Yep. And with the height of this thing, the nice thing there would be that, right now you're talking about the amount of space you've got for that processor cooling. With that liquid cooling block, you can compress that down quite a bit. So you have a lot more room, a lot better airflow. All around it's going to be a better form factor. That's pretty cool.
Yeah, and it'll fit full-size video cards as it is. So if you just needed like a legitimate Revit system, with an i7 processor and RTX 2070 or something, it's really nothing's really going to get much better. The Striker would offer the overclocking, of course, but it opens up the door, I think, for a whole nother type of build that people.
Yeah. Hey, there we got Buck. Let me merge him in here. Hey, Buck. Oh, he's walking out on us. I'm going to merge back. Just got him in and he just steps out. It's all good. Well,
at least he had shorts on.
We're going to jump in and talk today a little bit about some RAM, right? We're going to be talking about how... Actually, before we get to that, one quick thing. Those of you who are coming to Midwest U, let me merge this across real quick. Midwest U is coming up next week, the 20th and 21st. I'm going to be there. Anthony, are you going to be there? I think you're going to be there, right?
I won't be there for this one.
Okay.
Got to hold the fort down.
Right.
I think it's Buck and Angeli that are flying out for that.
Sounds good. Well, if you guys want to talk to us live about some of these things that we'll be covering, we're going to be there. I'm going to be there live at Midwest U. Buck's going to be there live at Midwest U, and we're going to chat about some computer stuff in person, live. So come by and say hello to us. We'll be there in the conference room floor. And I think, Buck, you're teaching a class, are you not?
No, I'm not actually teaching the class.
You're not teaching, okay. I think I got to get your audio turned up just a little bit here.
Okay, sorry about that, guys. I had a little computer error. Couldn't get the microphone cord, and then couldn't get my settings right. So.
All right, no worries, no worries. Well, we are going to be at Midwest U regardless, so we're looking forward to seeing you guys out there. And yeah, so let's kick off today's show. Buck, you and I did not get a chance to collaborate ahead of time. I was hoping to catch you on the drawing for the first two shows we had. I've got some names on my side that I was going to throw out there unless you wanted to add a few to the list. Before we do this, we can perhaps collaborate real quick for a few seconds offline. But if not, we can just throw some names out there as to who wins week 1 and week 2's drawing. What do you think?
I have a couple of collaborative. I have Kurt Johnson.
Okay.
I have John Ratton. I have Jason Boeing. I have.
And so hang on a second. I got to insert some names here. Jason. Who else? You said
Matthew
Josh
Havlin.
Rattle. You said I got him in there.
Yep. Excuse me. No. Josh Boeing. Jason Boeing. Excuse me.
Jason Boeing. I got Jason. I have Josh. I have Robert for week 1. Kurt week 1.
Matthew Havland. HALV.
I got him on week 2.
I had him on week 1 as well.
Oh, perfect. We'll put him in there week 1.
And that's all I have right now.
All right, all right. Let me just make sure this is all up to date, guys. Sorry about this. We're just getting this ready to rock for everybody so we can get this to be a fair drawing. Let's see. 6, 7, 6 to 9.
Oh, one more. Excuse me. One more from the email. Kyle Glines.
All right. Sorry, guys. We're just getting this locked in so we have a fair drawing here. Doing this live. All right.
Whenever I hear that we're doing it live, I think of that one politician dude that screamed it out, or or no, the commentator. I don't know how it goes. I think it's a meme.
Yep. All right, so this is what I got. After hitting the random button an undisclosed number of times, Excel came back and gave me the names. So week number 1 for the drive, I've got Jason. Okay.
Nice.
Got that on your side, Buck. Week 1 is Jason. Week number 2 is Matthew. I got Matthew for week 2 for the laptop. All right, congratulations, guys. Jason gets the drive. Matthew, you're getting the laptop. We'll figure out at the end of the show today if we're doing a giveaway for this week. And so, Buck, you can think on the fly if you want. We're still doing all of the names that get entered, by the way, are in the drawing for the overall at the end, where CTC is giving away a BIM project suite. And, Buck, I've forgotten what it was you guys were giving away for the end.
We were going to give away a desktop.
The full desktop, that's right. Fantastic. So make sure you guys keep entering. We're going to be giving that stuff away. We want to make sure that we're keeping your interest, 1, on content, and 2, because, hey, who doesn't like free things, especially really nice free things? So, all right, that's saved. Close that down. Let's get on to the topic of RAM. We're going to talk for the next 20, 30 minutes about RAM today. And Anthony, we're going to pick your brain like crazy. RAM is something that I've always had questions on. I did a little reading on that and watching that video that you sent me. Unfortunately, I can't get the video to play today. So guys, real quick for your knowledge, and I have this linked in the show notes down below, but I'm going to merge this across. We have how do memory times work. If you want to know a little bit more about this from just a technical aspect on memory timings, this guy here is going through it in pretty great detail. Again, I can't show the video just because, well, I could show it, but the audio isn't coming through, so it wouldn't be all that interesting. Anthony and I and Buck are going to talk about this and how we set these systems up for BIM. just using some other sites. We're going to use Newegg, for example, and talk about some RAM timings there. Another quick link, Anthony, that you had sent me that you might want to talk about here is Crucial's website, talking about memory performance versus speed latency. I think that's a big topic that we'll be kind of covering throughout the day. Talking about speed, talking about latency, just what does this all mean? So when I'm looking at RAM, Anthony, what am I looking for? There's two things primarily. What am I trying to go for here?
Well, like, ultimately, at the end of the day, you need enough RAM to do what you're doing. That's like the most important thing. If you have the fastest RAM in the world and you don't have enough, and page filing sends it to your hard drive, you're having a bad day. So number one, most important, make sure you have enough RAM. And number two, have the fastest RAM you could afford, really, is what it comes down to. And so when we talk about fast RAM, that's where, like, it becomes a big topic is what's fast RAM? How do you take advantage of it? Hey, I bought fast RAM and it didn't work, or this or that. That's kind of where the topic of RAM gets interesting.
Yeah.
If I'm
going to go spec out a system, Anthony, if I'm going to sit down, we already talked about CPUs. We talked about processors. We talked a little bit about the cooling of those processors, the delidding process and the speed of that. Ultimately, when the processor is doing stuff, it's going to push information off to RAM, right? When it's processing, it can't hold it all in its own cache. It has to push to RAM. That in and of itself is a little bit of a bottleneck, but it's one that we really can't avoid. So when we're going to RAM, this is where you're talking volume, right? Like how much RAM the RAM can hold. This is so that we're not caching to the hard drive as frequently.
Yeah, and basically RAM, all it is, it's like it's literally just your desk that you work in front of. If you have too much RAM, it won't do you any good. But if you have too little RAM, you'll start stacking papers on top of each other. Stuff starts falling over. So once we've decided how much RAM you need, it comes down to the topic of speed, really. And just to keep it simple with DDR4, that's where we're at right now. 3200 megahertz is my favorite speed to run. Intel's current line of CPUs might be standardized at 2666 megahertz. I didn't fact check that. It might be 2400. But basically anything above what Intel says their processor will run is considered an overclock. So when you buy RAM and you see a 3200 megahertz kit, that RAM is overclocked from what the DDR4 standard may be. So therefore, your CPU has to overclock itself to run it at that speed. I don't know how technical you want me to break this down to, but simply put, let's say you buy the most expensive RAM kit. It's a 4500 megahertz kit. It costs you $1,000, and all of a sudden, your system blue screens. It's just not happy. It's not handling it. That's because you might have a memory controller bottleneck. The memory controller is what interacts with the CPU and the RAM, and it's actually built into the CPU nowadays. It used to be something on motherboards. So you got to be careful where you buy, and that's why I like the 3200 megahertz kit.
It's a pretty safe speed.
Yeah, it's safe, and here's the tricky thing too. Things that stress the memory controller. Your RAM speed will stress it, your timings will stress it, your quantity will stress it. So let's say you have a 3600 megahertz kit, you're doing great at 16 gigabytes, you double your RAM capacity, and now all of a sudden it's unstable. That's because now your memory controller is just running out of steam. It's like, look, I was happy at 16, 32. You'd either have to literally just dial back your speed, and sometimes that means you got to run at the Intel spec of whether that's 2666 or 2400 right now. That's where Intel comes up with that number. Like, hey, we're certifying our memory controller to run at this speed, no matter the quantity you run. It's just a lot better than.
Yeah, when you're building systems, Anthony, what kind of speeds are you typically putting in? Like, you got a range of what, 32 to 3600? Is that what you're doing?
Yeah, we've done a few systems. I think we've benchmarked internally at 4,000 or 4,200. Buck would probably remember more than I do. But typically we like to spec 3,200 megahertz because it's reliable. The yields are basically 100%. 3,400 megahertz it's easy to run too, but as we talk about later, you'll find that latency doesn't really change much. I'd rather have 3,200 megahertz with good timings than a sloppy 34 or 3,600 megahertz kit. So 32 is just kind of where we standardize, and we try to keep it with good timings. And you know, 100. I mean, but technically, the Intel memory controller itself will do good up to about 3,600 megahertz. That's where things start to, you know, you need to start adding extra voltages and stuff like that. So
this is part of when you guys are building a custom system, I think, Anthony, where you're doing a lot of your custom tweaks, where you're kind of playing with voltages and things like that, right?
Yeah. One thing to talk about, I guess, right now is that Intel has the XMP feature, Extreme Memory Profile. So basically, Intel's saying like, hey, RAM manufacturers, we've created this technology so that you could tell our memory controller what voltages you need, what your timings are, to hopefully eliminate any user error, so that technically normal people can just enable the XMP profile and it should do all the voltage adjustments for you, so it'll run right out of the box. Keyword is should.
Should.
Yeah. Yeah, exactly. So once you get up to memory speeds that are so high, the voltages may be too high or too low, and there's a lot of issues. Typically, XMP profiles will overvolt. They'll give your memory controller more voltage than it actually needs. So we're inputting, while we may do XMP for timings, our voltages to the memory controller are all done in-house for our own system, and we'll add voltage if necessary, but we have our own low baseline and we go up from there.
Sounds good. Now, I want to take a step back, if I can, for just a second. Buck, when you guys are taking a look at memory volume, the amount of memory you put on a system for Revit, for a Revit box, since we're talking about BIM, this is the BIM broadcast, when you're talking Revit, how much RAM do you typically recommend for your average Revit user?
I mean, it really depends. On the average Revit user, I'd say 32 gigabytes is enough. I think where we find people, when, just to be completely transparent, when I was working at Balfour Beatty, I wasn't doing a bunch of things at once. I'd maybe be doing Navisworks and Revit, have one Revit model open. I got away with 16 gigs. What we see on a lot of our clients, though, is they'll have one or two Revit models open. They'll have a couple, you know, detailed fabrication models in AutoCAD. They'll have a Navisworks model open. They'll have a couple other programs open, to where your average user, the Revit model is not huge. They're not doing a ton in Revit. They have all these other ancillary programs running in the background, where that bumps them up to needing 38, 40 gigs of RAM. So to be safe for those people, 64 gigs. But I'd say your average architect, your average person that's in and out of Revit every day, 32 gigs is more than enough. And this kind of goes into play with what Anthony was talking about, not to get away from that. You know, the XMP profile is they have XMP ready and they have XMP certified. Certified means it's been tested, it can run at these speeds, you put it in the computer and you're good to go. Ready means there's going to be a lot of playing around with voltages. It can do it, right? But we're not going to spend a lot of time doing that. And when we kind of think about this, and when we think about volume and capacity, we kind of want to think about it like a race car. Like every Mustang that comes off a Ford dealership lot can do what it's supposed to do. When you get to the Daytona 500, you know, we want to go 200 miles. We want these tires to last 24 hours. That's kind of the more mentality we're getting into, right? We want that sweet spot on RAM. And there's so many things that come into play, right? The motherboard has to be able to support it. The memory controller has to be ready for it. And all these things are variable chip to chip. And when I say variable, if you look at 1,000, you'll see variations. If you look at 5, you might have 5 that are great out the gate. So on a production scale, we kind of have to draw that line. DDR 4000 RAM, and we've even bought XMP certified DDR 5000 RAM. You put it in a computer and it doesn't necessarily do that, right? So as a production company, when we want to say, hey, we're going to do DDR 3600 on everything, in order for us to guarantee that, we might have to buy DDR 4000 speed RAM and underclock that to 3600. at that point, we have to make a decision. The 1,000 speed RAM for 16 gigs is close to $1,200. 32 gigs is going to be $2,400. And it's not like you get two DDR4000 kits that they just batch together and they work together. It's not like that when you get that speed. You really have to look at that. Well, we're going to roll the dice on 32 gigs for 2,400. If we have to dial it back at 3,600, does that make sense for our customers? So from the business side of things, we try to find a really nice sweet spot. Now, when we say 3,200 to 6,800, we try to find a good sweet spot on that. We have had 128 gig kits that were in our Raptor, and I believe the one that y'all have, it's DDR3866. Anthony took it out of the box, put the computer, turned it on, and it just worked, right? So, so there's a little tweaking to it, and that's what Anthony and the team does. But as far as the volume, we want to be mindful in that the fastest thing we can get for 32 gigs might be faster than what we could for 64 gigs, right? So we don't want to give you more than you need, but 32 gigs for most architects save Aaron Maurer and people that are upgrading lots of files. And Shawn, just to let people know, and this is what we ask our customers to do, if you right-click on the Windows key, and you can do this on yours, click on Task Manager, and it'll pop up your files, select Performance, and then go to Memory.
One second. I'm going to do this live on screen here with you guys. So let me merge this across here. So we're here. We're on Performance. Yep.
Okay, so if you look over there, you have 29.4 gigabytes out of 39.8 committed, right? So you're using right about 30 gigabytes. So 32 gigabytes, if this is all you're doing, and I know people get scared, they're like, well, it's 29, man, I should just get 64. If you have everything under the sun open at 29, you're probably pretty safe at 32. I know Anthony might disagree with that, but if it's going to be another $1,000 to give you just peace of mind on RAM, right here, actually, you're only using 13.5 gigabytes. Excuse me, I was looking at the wrong line. In use, 13.5, available 18. 32 gigs is enough for you. So what we tell people to do is open up every program, the time of day when everything is open, look in here and look at your in use, and then round up to the next, 32 or 64.
Now, we don't really. I want to talk a little bit. I want to jump in there just for a second there. When you're doing this with Revit specifically, Revit is a bit memory hungry. So when you're doing this test, open up everything. Yeah, go for it. But make sure Revit's been open for a while when you want to do this, because if you have a project open, you've been working for 4 hours, you're gonna be you're much more accurate about what Revit's going to consume at that point than if you just open up Revit and maybe open a project, because it's going to continue to consume throughout the day. Revit doesn't give memory back until you shut it down and then turn it back on again. Some of you who are running into problems, we recommend that you shut down your model at lunch, come back and open it up after lunch, because that lets Revit clear RAM and you can get a lot of that resources back. Still, this is a good set of numbers to kind of go from. Yeah.
One thing too, while we're on this page, Windows itself will usually, I don't know if it's gotten better more recently, but it'll page file. It'll let's say you have 32 gigs of RAM. Sometimes it'll page file 32 gigs of your storage. Commit that much storage to offload from RAM to your storage drive. So that's kind of why you see committed, you have 39.8 gigs, even though you physically only have 32 gigs of RAM. That's because it's including some page file data in that amount right there.
Right. So to be clear, that's effectively, my math might not be 100% right here, but the in use and how much it's got committed generally will be pretty close to that number there.
Yeah, it could go up. It depends on how much it wants to offload, and sometimes guys will manually tweak their page file settings. I used to do that, but it's kind of tricky because if Windows wants more page file and it doesn't have it, it'll blue screen your computer. So I leave that for more advanced users. Yeah.
Also, if I recall correctly, and we're going to get into this discussion a little bit when we talk about hard drives in the next session, I think with a mechanical hard drive, if you guys are still running mechanicals, that page file space generally has to be contiguous.
You just said a bad word over here, man. Yeah, mechanical hard drive.
Well, man, come on. People still use them once in a while. There are people who still go to Best Buy and buy computers off the shelves, or they go to Dell and they get a stock computer, and it's sad, but that happens.
It's true.
You can't control your IT sometimes.
And then Bug mentioned another.
Talking about RAM.
Well, one thing to look at on here, and I just want to point that out, is if you go to the right of the in use and available, you see speeds, slot used, form factor, and hardware reserve. On the slots used, that gets important on performance as well. And this is something I don't think a lot of people look at, right? So you can get 32 gigabytes. If you have 32 gigabytes of RAM in your computer, there are probably 4 or 5 ways that happens, right? And that will affect your performance. Right now, we're using 404, which means we have 2 channels, okay? Depending upon the chipset, it also dictates the channels. The new i9s, you can get up to 4 channels. Channels are similar to a RAID, where those 2 RAM slots are working together as one. So if you went out right now and bought a very expensive single chip 32 gigabytes of RAM, you wouldn't even be in one channel. I mean, you'd be running 1 chip of RAM. You could get 32 by 2 of 16s, and then you got to have single channel RAM, or you could get 4 slots of 8 and have 32 in dual channel RAM. Dual channel RAM is going to be the faster setting. The reason you kind of have to be mindful of this, especially when using high performance RAM, and I'm going to kick this to Anthony after this because I'm sure he's going to have a little bit to talk about on this, is so when you get to a higher capacity, if we were trying to get an i9, 64 gigs of RAM, but say, hey, next year we want to jump to 128. If I bought a 68 gig kit, 8 gigabytes per chip, I don't have an ability to upgrade, especially if it's batched RAM. So we're kind of making that sacrifice. And getting a higher capacity, like a 16 gig chip that goes DDR 3200 or DDR 3400 speed RAM, as opposed to an 8 gig chip that goes that fast, it's dramatically more expensive. So a lot of times you'll see a computer manufacturer say, oh, I got you 64 gigs of RAM, and it can hold up to 128, but you're buying a whole new kit of RAM if you want to go to 128. Whereas we try to be mindful, if it maxes out at 64, we want to leave you 2 slots to grow into. Right? And that's another thing. We might not want to get you 4,000 speed RAM if you're going to grow into a system, because you'll never find the batch RAM for it. You'll end up buying a new RAM kit anyway. At the 3200 sweet spot with a really, really good production RAM, more than likely you'll be able to find that RAM available on Amazon or on Newegg. So in the production side, that's one thing we have to look at. But slots used is important, and I think, well, never mind. I think most people right now probably know their capacity, and they don't know how many slots are used. They don't know the speed. They don't know the latency. So this is a great episode. But Anthony, do you want to touch kind of on slots used, channels, and all the above?
Yeah, absolutely. The other thing, like Buck said, when you insert your RAM in the motherboard, let's say you're only using 2 of 4 or 4 of 8, you have to make sure you insert them in the correct orientation, or they'll never enter their prospective channel. So that would fall on reading your motherboard manual. But that's one thing we exactly do is, if the chipset's maximum is 64 gigabytes, then what we want to do is reach, half of that would be 32. We'll do 2 16 gigabyte kits so that in the future you can upgrade and you don't have to buy a whole new 64 gigs. You could just add 32 more. That's partially why we don't go, to the limit on RAM, because like Buck said, selection in RAM is always changing. Like just the other day, our distributors had access to smoking fast timings on 3200 megahertz. And I'm like, wow, I haven't seen these timings in a while. It's just the batches that these manufacturers get released. So we're not trying to get balls out fastest RAM every time, because then you won't be able to a year later when you want to add another 32 or another 64. Right. The thing is, your RAM is going to only operate at its slowest speed common denominator. So if you had a 3200 megahertz kit and a 3400 megahertz kit, you're effectively stuck at 3200 megahertz. It could even cause blue screens if the timings aren't all the same. So typically you want to always get a matched kit, like where all 64 gigs are matched. They're tested together at the factory, and then we get to test it together. But that's in a perfect world, and that's why we choose what we choose, so it's easy for the end user to upgrade in the future as well. So yeah, I don't know if I answered that fully.
And for Revit purposes, Shawn, because we're going back to how this affects the end user, there is a diminishing return. We did an article with the MCAA on hardware. where we had some really high speed RAM, and we went and messed with the timings and went from 3,000 to 2,600 or 3,000 to 3,200 to 3,400 up all the way to 4,000. And due to the latency, which we'll get to, there is a diminishing return. Like, it just doesn't keep getting better, right? You get to this point where you're kind of creeping along in the performance on your score. You're not seeing a 2-second drop or a 3-second drop anymore. In fact, you're probably seeing like a 0.5-second drop. And when you look at the cost, I mean, for production, the cost for batching, the cost for all that, it really becomes diminishing return on the investment. So, you know, that's really where that sweet spot is. I mean, I think it might have been 6 months ago, Anthony, when the DDR5000 speed RAM came out, and you and I were going crazy on drives, and I was like, let's make an Optane RAID. Let's get the DDR5000 in there. Let's throw some of that at cache, and let's bust out a 5.3 gigahertz and see what it does in Revit. And we found out some things, but you know, it didn't make. There's still some bottlenecks in there, and the 5,000 speed with a latency of 20 or 21 wasn't nearly as good as that 3,600, you know, CL15, right? But we'll get into some of the latency, because that becomes important for Revit, how fast you get that data on the processor.
Yeah. So I guess it's a good way to just start talking about the actual speeds of RAM. We kind of talked about capacity. Now, when people are being mindful of their systems, all right, I got 3,200 megahertz, but we see this 3,600 megahertz kit online. Why is the 3,200 megahertz faster? I don't know if you want to jump to those Newegg tabs where we could actually show people what they might see if they're shopping for RAM themselves. We have two different sets of RAM, where one's a 3,600 megahertz RAM with 19, 20, 20, 40 timings. I think you have them open already, Shawn.
I do.
The ones at the top.
I was going to pull this up on screen so you could kind of see. Also, when you're shopping through, we had filtered out 3,600. We had filtered out 3,400, and we were looking at specifically 32 gig kits. So for those of you who want to reproduce exactly what we're looking for, we're up on Newegg in RAM looking for these two things, 3,600, 3,400, and limiting to some common denominator here. So that's where we went, and we picked two memory kits at random out of this, sort of at random, sort of kind of handpicked it a bit, and we pulled them off to separate tabs up here at the top.
Yeah, we wanted to kind of get something within the same price range, and what we came up with was a 3,200 megahertz kit with smoking fast timings, 14, 14, 14, 34. This is a really good price. About 2 years ago, this would have been probably closer to like $700. So it's 3,200 megahertz. I'm like, okay, cool. That's faster than Intel's 2666. But then if we go to the next tab, you'll see 3,600 megahertz RAM. Okay, wow, that's like 400 megahertz faster. It's got timings 19, 20, 20, 40. That first number is your latency. That's the CAS latency, or sometimes you'll see it as CL. But there's a formula to calculate your actual real latency, where you put a time value, not just a sequence, because 19, 20, 20, 40, that's a sequential number. All of those things are happening in a sequence. Once you assign an actual time factor to that, you'll find that the 3,200 megahertz kit comes in at a latency of 8.75 nanoseconds, and the 3,600 megahertz kit comes in at 10.5 nanoseconds. So the 3,600 megahertz kit's actually slower.
Yeah, two nanoseconds slower, give or take.
And that may not sound like a lot, but when we've done benchmarking, you go from 2133 megahertz to 3,200 megahertz. That's like 3 seconds off in Revit form, the RFO benchmark. That's right. Like 3 seconds faster. If you go from 2666 to 3,600 megahertz, that's already like another 2 to 3 seconds faster score. So going from Intel stock settings to, you know, perceived like 3,600 megahertz could drop you 6 seconds in Revit, the Revit forum benchmark. And if someone's shopping for RAM, you want to be mindful of what's your actual real latency, because sometimes the bigger number isn't always the fastest.
Right.
regarding
now,
the
Anthony,
CPU.
can we share that exact number, that exact formula that you ran on your side with the audience here today?
Yeah.
Maybe I can
And
pull
I
up an Excel
think,
spreadsheet. We can like run the numbers live in Excel. What does that sound like?
yeah, we could do that. If you want to set up the document, and I think this formula was mentioned in the YouTube video you have linked. There's a couple different formulas that you'll find out there. They all kind of achieve the same number though, but it's you get your latency, which would be that 19 or the 14 that we saw. You divide that by your.
We'll put in the 19 from this particular page.
Cool, and then you get your advertised speed, which would be that 3600 megahertz. That's on the page. You so you divide latency by RAM speed, then you multiply that by 2000.
I don't really like these.
Just to chime in, guys, on the Wikipedia page under CIS latency, they have the timings in this chart set up for you.
Nice. So I don't have to
and then once you
instead of Excel.
Once you do that, then you get. Once you do that, then you get your actual latency in nanoseconds.
What was it, 3200? I think we had in the other one. Yeah.
Correct. Yeah.
Yeah, so we can get those exact same numbers that you were talking about before. So it's latency divided by speed times 2000. That's the basic math there. And so we get the real latency based on that. So we get the same numbers that Anthony was mentioning earlier.
If you want to plug in the actual JEDEC standard, when DDR4 first came out, it was latency of 15 and 2133 megahertz. And then I think current standard might be CL16 with 2666 megahertz. This is what your like Xeons, your brand spanking new Xeons would have. Like with a Xeon, you cannot overclock the RAM. You would be stuck at 2666. Sometimes Xeons might get a little bump in timings. They're very, very, very conservative. So you could see going from the 2666 to the 3200 megahertz. I mean, we're talking like 3.5 or almost three nanoseconds.
Right.
That makes a big difference, in Revit actually when you start benchmarking it.
Yep.
And just to remind them, I mean, when your computer is running, you're on RAM. I mean, that is the medium that you're transferring data to, right? That's how your computer is working. And I know we've used the race car track. Imagine racing your car around a track that was gravel compared to slick. You know what I mean? That your data is flowing faster through the computer. People that have used a really high-speed RAM with a low latency, it's snappy. I mean, when you click it, things happen fast, files open quick, and vice versa. So, this is one of the big reasons when you look at processors. When we start looking at processors for Revit, since it's so RAM heavy, we wanted to get away from the Xeon because the ECC RAM, it's just slow as a snail. I mean, there's no getting around that. You have a 5 gigahertz computer with ECC RAM, you're still waiting for things to happen. So that's why
I want to kind of.
Yeah.
Go ahead, Buck. I'm sorry, man.
You got it.
You can finish your soon. And then to tie this into the CPU, your cache is writing at about 3 times the speed of your RAM, maybe 4 times the speed of your RAM. So while these numbers, like, man, that's super fast. Well, your CPU cache is like 4 times faster. So if you were to benchmark your RAM, that 3200 megahertz kit might be writing 40,000 megabytes per second, 40 gigabytes a second. That's about your throughput of your RAM. Your SSD is even slower. So your cache is something over 100, gigabytes a second. It's downgrading to RAM, which is like 40 gigabytes a second. And then, Lord forbid, you don't have enough RAM and you're going to write to your SSD, which is, if you have an NVMe, you're at 3 gigabytes a second. So that's why, in a perfect world, yeah, we'd have enough cache. But
Right.
you know, in the real world, we depend on our RAM, and you just want to make sure you don't ever have to go to your hard drive, whether that's an SSD, NVMe, or spinner.
Right.
So
Well,
yeah, good Lord, don't use spinners. You're going to give Anthony a heart attack.
yeah, man, I'm gonna like walk out of this stream.
That's right.
so
That's
this
right.
is interesting.
None of that garbage.
We talk about features, not to get too far out front, but you know what Anthony said is really important when we think about where technology and computers are going to go, and this is kind of where I get the geek out. Right now, you know, you don't have any solid state drives or RAID drives that can push 100 gigabytes per second. If we did, though, theoretically, we could get a drive that could go as fast as RAM. The cache on the processor is still 3 times faster than that. So now let's imagine we have drives that can go 3 times faster than that. Now it's on the processor being the bottleneck, right? It's going to be interesting because at some point we know we can't just keep making this processor faster until you get to a quantum computer and you're measuring states. But what is a drive going to look like? At some point, we're at the limitations, you know, of transistors. We're at the limitation of what a drive is. And kind of thinking about how to move that much data, you know, you get in the synapse and all the different ways that people are looking at building, and Intel's even doing it right now, you know, processors and things that work like your brain. So I don't want to get too far down the road, but as of right now, RAM and the cache is not a bottleneck, and it's not going to be for a long time. I mean, until drives can go as fast as RAM or as fast as cache on a computer, which they don't. Right. The reason RAM can do it is because it doesn't have to store anything. Power goes out, it's gone. Right. But long-term storage is always going to be that bottleneck. And that's why when we're looking at some of the technology today, man, even if you made RAM 3 times faster, you're running into a CPU bottleneck. Right. Yep. So trying to look at the headroom we have, because we get a lot of times, Shawn, people say, well, should I wait for next year's model or should I wait for the year after that? No, this is really, really good stuff. We're at an interesting time in computing where 5 gigahertz is possible on all cores, and where RAM can go, you know, 100 something gigabytes per second. So it's an interesting time, but looking out in the future, you know, to spark that, what does that look like? We got a lot of headroom, but right now we're seeing a lot of really good technology shortchanging the medium.
Yep. One thing go ahead. Oh, go ahead. I was going to talk about the memory controller a bit. Just very, very like, you know, simple data where not all memory controllers are the same. Your memory controller with the same exact RAM, like, I mean, I don't want to like make AMD look bad or anything, but your memory controller will determine whether you could run certain RAM or not. And even if you have the same 3200 megahertz kit in an AMD system versus an Intel one, Intel's memory controller is just so much better. It's going to outperform the AMD memory controller. So despite having the same RAM, you're still getting more performance out of Intel's memory controller. So that's a factor just to loosely consider when choosing AMD versus Intel. You know, like AMD is doing great, but that's one reason why we choose to just stick with Intel.
Right on.
Well, and that's a fallacy, because I think I have touched on this. We get so many calls about it, Shawn. People look at the new Threadrippers, 32 core, 64 thread, and they're like, oh, this is amazing for point cloud processing. But I think if there was one thing I had to do right now that would horrify me is to put a 128 gig kit inside of an AMD Threadripper. Anthony, I know you might disagree with this a little bit, but when they rolled out the first Threadripper, it was so bad that one of the fixes for 128 gig kits is put 7 RAM chips in, get it to post boot, set your clocks, and then add the 8th chip in afterward. That was a fix to 128 gig kit. No, this just gets down. I mean, this is where, when we talk about reliability, that 32 core processor might really only like to play with 64 gigs of RAM. And if you're point cloud processing, the more RAM, the better. So not to just kick AMD again, just nightmarishly 128 gig kit with anything outside of stock. Saying we had, you know, the 3866 gig kit that worked in an Intel computer. If we put that in an AMD computer, I do not believe it would run at that speed. And that goes down to that.
Yeah.
I wanted to jump to user comments real quick here from the YouTube feed. Matthew wrote in and asked a question. He said, "What about registered RAM versus non-registered RAM?"
That just basically comes into play with server chipsets. you know, the Xeon line, you have no choice with consumer stuff. It's all, you know, non-registered RAM, so it's kind of we can't do a comparison because the i7 line, for example, it doesn't run ECC RAM, which is your registered RAM, but at the end of the day, I think there's a slight amount of higher latency because it's writing the data twice, but I don't have apples comparisons between the two.
See, server RAM, from my understanding, server RAM is primarily built around data integrity and checking. So that's where you're saying it's writing the data twice. It's doing 2 times the work. Not necessarily any. It might be slower. Probably is slower because it's got to do those extra, you know, ticks every time. But that's because you want to make sure on a server environment that when you're transferring data, when you're getting information and doing, you know, database entries, that information is solid. On a PC, on a user's consumer workstation, it's a little different because you're trying to go for speed, you're trying to get stuff done quickly, and while you want your data to have integrity, it's not like a server environment where data integrity is the king, right?
Yeah, I strongly feel that the only people that need error correcting RAM right now are literally servers, like literally. I respect, there's people out there that I respect that'll say, well, I won't run anything but a Xeon in a workstation. And I'm like, dude, we're way past that. Like, chances are your software is the most unstable thing in your system, not the hardware. So, and that's why we build in some buffer. We're not getting 4,000 megahertz RAM for every system we build. We know the limitations of the memory controller, and we're well, you know, within the safe zone where, and we fully tested. We'll write at least 700% on a memory controller and the RAM combination before we call it good. So, you know, there's that. But and then when you have a Xeon, you, go ahead, Buck. Yeah, it's like with Xeon. You got no choice. It's like your CPU's memory controller will dictate what you run, so you can't really, you know, it's hard to compare apples to apples between the two.
But
other than we know faster RAM is better.
I was going to chime in. The Xeons and the ECC, it's a 9-bit as well. It's not an 8-bit data set, right? That 9th bit is for the error correcting if something gets corrupted, that it can kind of fill in the void. Having said that, you still get blue screens with error correcting RAM, and you still get blue screens with Xeon due to the fact the software is the most critical thing. And, you know, I got to give a shout out to our IT managers out there right now. The last few Windows 10 updates have been abysmal as far as wreaking havoc, and I think a lot of our clients called in and said, "Oh, we did auto updates, we forced it through, and now we're getting blue screens. You know, what's wrong with the hardware?" And it's kind of like, what changed? You know, and it's the software, and I think that's one of the things that, and this goes back to Mac, right? Mac controls the hardware that's in their computer. They can debug everything because they know exactly what's in the computer, so they can run a lot of that updating, so you don't have the blue screens as much on a Mac. Whereas Windows, they take any bit of hardware out there, any bit of software out there, and they have to plan for both. So I don't want it to be a knock on Microsoft. Microsoft is serving dramatically more people than that. Well, you know, you got to think. You know,
well, they've eliminated a lot of quality control. But you're right, Buck. You're right.
But I mean, when you look at the hardware that they'll accept, and trust me, I built a Hackintosh, not for sale in case Mac's listening, Apple's listening. Injecting drivers into an OS to make sure it runs, and oh, is it an EVGA, you know, or is it MSI, or is it, you know, somebody else making the graphics card because it has a little different way to talk. You know, one of the things getting to that is it gets down to the actual hardware language. Like a lot of people call us and say, hey, you know, the memory controller on the 9900K is only certified to 2666. How are you running 4,000 speed RAM? That can't be so. On every RAM module, there is a SPD chip, which is serial presence detected. When you put it in your computer, it reads that information and says, these are the timings that can be run on this. From a mechanical level, when you start putting electricity through this, this is what can be expected. This is how we need this to work. on the XMP line, when they're certified, the manufacturer is certifying using the JDEC code, which Intel created, which is a standard. This is going to run with these timings, and it's actually stored on that chip. This gets back to, once again, it might be stored on the chip. The motherboard you have might not be able to handle that kind of timings. It might not be that fluid, right? Your processor might not be able to handle those timings. So there's some other things involved, but I mean, it really gets down to, I mean, a mechanical level on a lot of this stuff, on the timings and latency and everything else. And I think people should look at RAM very much like a CPU, and I didn't before we started going full production. There's variations, right? There's variations in tires. If you build 1 million tires, some of the rubber is great, some are not. You're gonna have recalls on some. Some factories building the same type of tire or same processor don't do it as well. I mean, Anthony, when you bin processors, you know, there's certain factories that Intel has that, like, they put out all the perfect processors, and everybody wants one from the Malaysian factory, not the other factory, right?
Yeah.
And if you get in the minutia, it really comes down to that. But you know, you can't get worried about all that stuff, especially if you're upgrading your computer. Right. You know, go to the chart on Wikipedia, look at the RAM timings, the nanoseconds, find the one that's in your budget, in the price, in the capacity you need, and that's a good decision. Having said that, it comes out and it's XMP certified, and it doesn't run at that timing. Don't be completely discouraged. You can send it back and get another one from Amazon and try again, or you can dial back the RAM clock speed a little bit. And just know that you're getting the most out of what you got. So just to chime in on that.
Perfect.
Yeah.
Any
not to scare
thoughts?
people about I'll just close on, because I mean, at the end of the day, this is all revolving around overclocking, and it's not a scary thing. You just got to tune for it. You know, you got to know what voltages to adjust. Intel and all of these manufacturers, they want as little, you know, warranty claims as possible. So there's so much built-in headroom. All we're doing is pushing it to that individual component's safe maximum. You know, because obviously some CPUs won't do 5 gigahertz, and that's why Intel clocks them at what they do or whatnot. What we're doing, we're just finding all the good ones and putting them in our computers. So whether that's CPU, RAM, or whatever.
Yep.
And Shawn, just to chime in, the last thing to say about RAM, while there are variations, RAM is one of the only components that we get with a lifetime warranty. So if you get XMP RAM certified running on your computer, that's a lifetime warranty. So when people are typically scared of overclocking, they're like, I'm going to burn my CPU up, or I'm going to burn this up. RAM's one of those things that if it goes the speed recommended on your computer, it is a lifetime warranty. You will not, using the XMP code, you will not get in trouble with burning up your RAM. Right. It will be a little bit warmer in your system, given that, but it does have a lifetime warranty. So it should kind of take some of that stigma or steam away from overclocking is bad, it's going to burn up and it's going to cost me money. RAM is one of those things that's not the case.
Right. So, drawing this back in my case, in my brain, back to the whole concept of what we were talking about, matching the system, getting everything tuned and working together. Going back to the car analogy, this is like you said, taking a Mustang out to the racetrack, right? When you do this, you're not going to like put some ridiculous transmission in the thing that can't be matched with the motor of the thing, right? You got to make sure everything's working together. You got to make sure you check specs. You got to make sure you do a little diligence there. But if you're within spec, if you're within range, that car is going to perform pretty well, or at least at what the manufacturer says. So
yeah, it's about balance.
Completely. Well, and one thing we didn't do, which I think everyone should, you know, because I think a lot of times people are like, well, why is this so expensive? If you go to a Corsair page or you go to the Newegg page and look for the fastest batch kit of 120 gig RAM, you'll probably fall out because that kit of RAM probably costs more than your existing computer. Just to throw it out there. So when you look at some of the big costs in the system, for us, RAM and graphics cards are almost identical. 32 gig kit of really, really fast RAM. You're looking, well, fortunately, you're probably in the $400 or $500 range. If you go up to the 128, you're probably in the $2,400 or $1,700 to $2,400 range for 128 gigs. So that's why it's important for capacity. Yeah, yep. But think about RAM capacity like a crane. If you have a 200,000 pound crane that can lift and you're only lifting 4,000 pounds, you're probably paying too much monthly for your crane, and you just don't need it. You're not ever getting any use out of it, right? If you need it, you know you need it. Check your Windows performance and go on and get what you need.
Exactly. All right.
And you'll
so
always get a
close
page
this
file,
show
so don't.
Oh, go ahead, Anthony. Sorry.
You'll always get a page file, so don't worry. Like, oh, I'm getting page file, dude. It's always gonna page file.
Yep.
You'll know if you don't have enough RAM.
Right. So before we shut this down today, Buck, are we going to be doing a giveaway for next week's show?
Yeah, I'm trying to think what would be a good giveaway for you guys. Anthony, what are you thinking, man? I was going to ask if you had that Stormtrooper, the white one that we did. It was a kind of prototype box that we scrapped. Is that still sitting around?
No, man, that's an AMD, dude. It's an AMD.
Uh-oh. We don't want to be giving away AMDs here.
I was thinking someone might use out of it.
Man, I don't know, dude. No, how about like an SSD or something?
I'll go with that.
I don't know.
We'll go to 512 970 Pro.
Yeah, that's cool. That'd be fun for anybody's system.
Yeah. All right, 512 970 Pro.
512 970. All right, so this is what we're going to do this week. We're going to have you guys tweet at us, just direct, not direct message, just tweet at us some information about your computer. Let's say what your RAM is that you guys are running now. Hey, at BIMBOX or hey, at BIM Broadcast, we're running X RAM and we'd love to be using blah. Tweet at us. That'll get you in the entry for this week's drawing of that 512 solid state drive.
And also for the folks that don't have an M2 slot, we'll send you an adapter card. And if you want to throw in the capacity that you're running fully loaded, that'll be interesting as well. We can kind of get a good gauge of what the people listening to this are actually pushing on their computer.
That's right.
Yeah. Keep in mind, if your computer's older than 3 years old, it's probably not going to have a supported chipset. But that's something to consider too. But I know
where you can get a computer that will support that.
Right? And you'll need at least Windows 8.1 because making NVMe work with Windows 7 is possible, but not easy.
Right. All right, guys. That's it for this week. Thank you all for showing up. We look forward to the tweets you're going to be shooting us, and we'll catch you in the next show.
Cool. Thanks.
Awesome. Thanks, guys.
Peace.
And girl. Yeah.